Question 39, 4 marks. Water and octanol do not mix. When an aqueous solution of bromoacetic acid is shaken with octanol, an equilibrium system is established between bromoacetic acid dissolved in the octanol and in the water. The equilibrium constant expression for this system is: an aqueous solution of bromoacetic acid with an initial concentration of 0.1000 moles per liter is shaken with an equal volume of octanol. Bromoacetic acid does not dissociate in octanol, but does dissociate in water, with Ka equals 1.29 times 10 to the negative 3. When the system has reached equilibrium, the hydronium ion is 9.18 times 10 to the negative 3 moles per liter. Calculate the equilibrium concentration of aqueous bromoacetic acid, and hence or otherwise calculate the KEQ for the octanol and water system. So just to give you a bit of background what this is all about. The octanol water system looks at a chemical's lipophilicity. Lipophilicity is the chemical's ability to dissolve into fats or oils. What you are looking at is bromoacetic acid, how much of it is dissolved into octanol and how much of it dissolves into water. When KEQ is a large value, then this means the chemical will dissolve more into the oil-like octanol. When KEQ is small, then the chemical substance will dissolve more in the water. In order to work out the KEQ for the octanol water system, we need to determine the concentration of bromoacetic acid at equilibrium. So first of all, we look at the dissociation of bromoacetic acid in water. It gives H plus and BrCH2COO-. When we write that in the Ka form, the product is divided by the reactant. We know that the Ka is 1.29 10 to the negative 3, and we know also the H plus at equilibrium is 9.18 times 10 to the negative 3. Knowing this, we can say the concentration of the BrCH2COO- is also the same as H+. So we simply substitute that into our Ka equation and determine the concentration of bromoacetic acid at equilibrium. This works out to be 0.0653 moles per liter. So once we determine the equilibrium concentration of bromoacetic acid, we then look at the information from the question and figure out the initial concentration of bromoacetic acid before ionization, which I've denoted as Y. The change X is 9.18 times 10 to the negative 3. That is from box 4, where it says the hydronium ion is that amount of concentration. We simply then take the equation 0.0653 equals Y minus 9.18 times 10 to the negative 3. Rearrange that to find Y. It works out to be 0.0745 moles per liter. Now we're going to take that number and work out bromoacetic acid in octanol. So take the information from box 1 and 2. We can write an equation. The bromoacetic acid total is equal to the bromoacetic acid initial plus bromoacetic acid in octanol. If we rearrange that to make bromoacetic acid octanol as a subject, then it becomes 0.1000 moles per liter minus 0.0745 moles per liter, which is the initial concentration before ionization. And this gives 0.02549 moles per liter. Substituted into the KEQ, which works out to be 0.390 with 3 sig fig. Thank you for watching. Please follow and subscribe to this channel for more quality contents. I'll see you next time.